everyone, welcome to my channel. So, if you're looking for some beginner friendly ML projects to add into your resume, or if you have already started learning machine learning but want to learn side by side, this is the right video for you. Today, we'll be talking about Walmart sales prediction. So, this is the data that we have. It's taken from Kaggle, and as you can see that there are lots of details on the website, but basically we are going to predict the sales of the stores. So there's plan, metric, etc. That is the requirement, but we'll be using regression model for this. We have four CSV files, which is features, stores, test, and train. Feel free to go ahead and click on each of the CSV files and explore. There is also this download button that you can download it into your system, so that you can save it, and we'll need that for our project as well. So that's it for the intro for the data. Moving on to the flow of the project. This is the flow, which is the basic ML flow. We have import, merge, quality, EDA, pre-processing, training, and evaluation. And the aim of the project is, as I said, is to predict Walmart sales. We'll also be analyzing the correlation of the data and also data visualization. The libraries that we have used are pandas, numpy, matplotlib, and scikit-learn. If you know them, it's fine. Even if you don't, we are going to go easy and slow, so no need to worry. The applications are inventory management, budget planning, etc. So let's go in Collab and code so that we can get started with the project. So this is the Collab environment. The first step that we always start the project is, or I start, is to import important libraries. So importing the libraries. Then we'll be moving to import import pandas as PD, and matplotlib as PLT. Great. Now moving on to our next step is to load the data. So as you know that we had four CSV files, so we'll load into the Collab environment so that we can use it in our code. So you see in the left right corner we have left corner we have this file, so we are going to upload it from our system. Meanwhile, I'll write train data and I'll save this in these variables. So yes, so these are the four files that I'll be loading. Meanwhile, I'll write the variable's name. And how do we load the data? We write pd.read underscore, just a second, pd.read underscore csv file, csv, and in bracket we put the file path name. Same goes for all the variables that will be storing the data in. So read csv, bracket, parenthesis, and inside there will be a file path name. So let's just write the rest of the variables, rest of the data set. Okay, so now let's just go copy path one by one and paste it inside the parenthesis. After the data is loaded, we'll try to visualize one by one. So let's just first take train data, or we can also take features data as well. So yes, let's now run the cells. So wait, it's giving error, PD is not defined. Let's go up. Okay, I wrote pandas as NP, sorry, so it should be PD. So now let's run all cells. This is fine, cool. So now we'll look at the train data and the features data. So you can see there are store number, department number, date, weekly sales, and if that day is holiday or not. For the we also see for the features data, we have store, we have date, we have temperature, we have markdown files, etc. So the next step would be obviously merging these data sets into one so that we can work properly. So let's merge the data sets. What I'll be doing is I'll be merging the train data and features data into one, and then combining this and then merging it with the stores data. So pd.merge stores data, comma, the second argument we'll pass is pd.merge, and herein we'll merge the train data and the features data, comma, features data. Cool. So we'll repeat the same step for our x test variable as well. Test data. Yes. So this is it. We have combined the features data, train data, and merged it with the stores data. Now let's guess the next step. What should be our next step? Yes, you guessed it right. We are going to check for the missing values and the type of attributes, the data type, etc. So when we say to check the attribute type or the data type of the column, there is one thing that we use, and I hope you might have guessed it by now, but it is .info. So you write x.info bracket. So let's just run this first, and then this. So we get, so as we see that lots of them are numeric, but we have no one type column and one is date column, which are of object types. We'll deal with that separately. Second thing is to check for missing values. So what I like to do always is to check the percentage of missing values in each columns. It gives me a better idea of the percent of data missing, so that I can know that if I have to drop those rows or I have to just fill it with a median or just what we say interpolate it. So number one thing I'm doing is calculating the number of cells, which is basically rows into columns. That will be doing for both of the x and x test as well. Same goes for x test. Okay, so we have here underscore, so let's just put underscore here. Cool. So this is done. Let's just now find out the missing values in each column for x. So it is x is null dot sum. Same goes for, okay, underscore. Same goes for x test as well. Cool. Next we'll do is to calculate the percentage. So we have missing values, percentage, such long names. Missing values count x dot shape 0 into 100. Same goes for x test as well. Now we'll be displaying the results. So let's print for x missing values, print missing. Okay, we'll copy this. Same let's do for x test as well. Let's run. So as you can see that we have lots of data missing, around 70% of data missing, around like in every column 60 70. So we'll be dropping the columns later on. Let's just now move on to the correlation of the matrix. So we'll be using f equals plt.figure. Fig size will be 12,8. Then we'll be using plt.matShow. So matShow is basically used for displaying matrices in a color grid format, if that makes sense. Equals f dot number. Now we'll be taking plt.xsticks. So xsticks are basically the side labels of the matrix. We'll be giving them the column names. which are of the number or bool type. Shape comma x dot select d types, again number bool dot columns. Copy paste. Dot columns, comma font size equals let's say 14, and we'll also rotate the text so that the reading is easier because it's on the x-axis. Okay, underscore, okay, dot, okay, fix size, what's wrong here, okay, equals to, correct. So this is it, let's just run this. No, wait, we need to do for the y text, we need to remove the rotation. Next, what we're going to do is cp equals to plt.colorbar, so that we have in right that color bar is displayed for better understanding. We'll write tick dot params and we'll give the label size equals 14. We'll also put the title, which is a correlation matrix, and let's give the font size as 16. Let's just run the cell. So here is the correlation matrix. Feel free to analyze and get more info about this. But as I can see, there's a weak correlation between weekly sales and size, and weekly sales and department as well. And between the markdowns, there is a different correlation between the weekly sales and markdown. So these differ a lot. So one thing that I want you all to do is, number one is to analyze the type that. So let's just go back and wait a second, let's just go back and write a code. Let's just see stores data. So if you see stores data, the type is not object or anything, sorry, it is object, not numeric or float, so it has abc type. So let's just find the so we write x dot type dot value counts, and from here we get the abc, the counts of a and b and c. So let's just this we'll convert this into labels so that we will be able to put that in our model. So data cleaning and pre-processing is a new step. As I said, I'll be dropping on the columns first, so let's just drop all the markdown columns. So x equals x dot drop in bracket columns equals yes, markdown 1. Let's just copy and paste this for all the 5. 2, 3 and 4. We need one more for the 5. Okay, we'll repeat the same for the x test as well. Cool. The next thing that we'll now do is to run the cell first, and we'll now handle the missing values. So there are still missing values in the unemployment and cpi columns on the test set after we have dropped markdown. So let's just write x test dot unemployment, which is the column name, dot fill na in bracket x test comma unemployment dot mean comma in place equals true. Same goes for xted with cpi column as well. cpi dot fill na x test dot cpi dot mean in place equals true. Cool. Now the next step would be is to encode categorical attributes, as I said, and also the booleans one. So we have type as categorical and is holiday as a boolean attribute because there's a true and false. So let's do mapping. Let's write create a variable type mapping underscore equals A2 B1, and let's map C to 0. Moving on to X type, so let's just write type equals X type. We'll be using dot map function and providing the variable type mapping. So type mapping is a kind of dictionary which has key and value pairs. We'll also use apply the same for the X test as well. Moving on to so this was categorical attributes. Now we'll map the boolean attributes, which was is holiday. So if I show you this, so false true, false true. So let's just do this. So mapping boolean attributes. Okay, let's copy attributes here also. Okay, then now we'll do X is holiday, which is I capital is holiday equals X is holiday as type int. So that will basically convert false into 0 and true into 1. Let's just do the same for X test as well. Cool. Let's just okay. Now the next step would be is to encode the date feature, which was in the form of date string. So since we are dealing with a time related features like months, it is very essential to know that they are cyclic in nature. So after January to December, again we'll have January. So this is cyclic in pattern. So these cases are handled differently. So these are either converted into sine or cosine form, so that we see the what we say variation. So for example, let's say that January 1, if it correspond to 0 degree, we'll have February 2 to 30 degree and so on. So I'm creating a function first. It's called extract year and month. We'll be passing date string. First thing I'll be doing is I'll be extracting the year and month from the date string. So a string will be passed, and a date string is a type of format or data type in Python. You can read more about it. So from that string we can extract year and month as such, and we can return year and month. So this is one function that we created, very simple. Now we'll encode for the train data. So let's create two empty arrays. We have year values and we have month values. So we'll be extracting year of each cell and month of each cell for X test and this test and X train. So let's say for date in X date dot values, and we'll say year comma month, and extract, we'll call this function extract year dot month, and we'll pass date, which is in the date string form. Then we'll also append that in the years value form, and we'll also append the month in the month values array. Dot append month. Next, what we're going to do is we are going to create a new column in the X which says year, and that will be using year values for that. We'll also be creating a new column which is capital M month, which will be using the month values for the data. We'll do the same procedure, all two procedures for the test data as well. So let's copy and paste. So let's just change X test. Cool. So I guess we are done here. Now we'll be creating a month sign and a month cost transform function. So def sign transform, it will take on values and it will transform those values into sign degrees. So np dot sign 2 into np, which is basically 2 pi into value divided by 12. I'll do the same for the cost transform as well. So let's say cos, and for cos we'll take np dot cos 2 pi into values divided by 12. So next is we'll create another column which is month sign, and that will store sign transform, and will pass on the x dot month values. We'll pass it as an integer values. Cool. We'll do the same for month cost as well. So there will be two columns, month sign and month cost. Same goes for the test data set as well. So we'll copy and paste. X test. Cool. Now what we'll do is drop the year, because year is just an integer and it does not carry any information for the prediction. So we'll only use because we know that seasonal change only it influences the prediction. So it is already carried in the month feature. So we'll drop date, month and year, and we already have month sign and month cause. We'll do the same for X test as well. Let's just run the cells which we haven't. Okay, cool. This is also, this also, and this also. So now let's see the shape. So I have written x dot shape and x dot shape. So we can see that one is 12 columns and one is 11, because we have extra weekly cells as well. So moving on, I'll be extracting the validation data set from our training data set. So let's make a ratio validation. Let's call it val ratio. And I'll keep this as 0.01, which is basically 1%. Then I'll be initializing validation indexes, and I'll be using the random dot choice. I'll pass on length int np.flow length x into validation ratio. So they basically this will randomly generate our validation data set from the data that we have. Dot replace equals false. Okay, it should be ratio. Next is, oh wait a second, yes. So xval equals s dot loc validation indexes. And then we'll be dropping it from the x. So x dot drop validation. So in the x, all the indices that we have randomly generated for validation, that will be removing it from our original x data set. So that is the whole four line is all about. If you did not got it clearly, you can put it on chat gpt and understand it better line by line, word by word. Next I'll do is I'll get the targets from the data set. So I'll be getting y equals to pt dot data frame, and x from x dot weekly sales I'll initialize as columns equals weekly sales, that we will get as y. Now we'll also do the same for y val, because we also need y for validation set as well. So xval dot weekly sales comma columns, just a second, yes, columns equals weekly sales. So this is the complete statement. Moving on to normalizing the data set. So we all know what normalizing the data set is, so I'll just copy and paste the normalization code that I usually use. In this, what we do is we usually divide each number by the mean and then divide by standard deviation, so the data is normalized. I've also stored the original x and x value in the non-standard variable as well for future reference. And post that, I have standardized x, xval, and x test for the model training. Next is to metrics definitions and calculations. So we need to analyze a model's performance through matrices. So that we'll be doing. So first we'll be defining RMSE, which is root mean square error. It will have two variables. It will have predicted and it will have target. So the algorithm, it goes as that, first we'll check for errors as well. So if length
of predicted, it's not equal to the length of target, so we cannot perform calculations. So we'll ask it to throw an error. So if length of predicted is not equal to explanation, length of target, return, just a colon, return error, target and predicted, length of predicted and target is not same. So that's it. Now if this condition is false, that means our lengths are same, so then we'll move on to calculation. So let's just store the n, just this n. So n is basically length of the predicted array, and will return is np dot round. Will try and round, let's round off first. So np dot square root comma np dot sum, np dot, okay, we also have to do power of what, predicted minus target, and power is 2, just a second, comma and 2, right. And we'll also divide the whole by n, and we'll round off the whole value that we have up to two decimal places. So for round at the end we'll be adding 2. Figured it out. So this is the formula for RMSE. We have rounded off to two decimal places. We have found the square root of predicted minus target to the power 2 under root. So let's just run the cells now. So the data is normalized, and we have calculated RMSE function. We have made the RMSE function. I'll do the same for the main mean square error. We also have TSS, RSS, and R2. These are all the other metrics. If you want to calculate, you can do it. If you don't want, I have already done for your reference. But I have only used RMSE and R2. So if you want to use this, feel free to do it. Next, what I'll be doing is initializing our models. So first I'll be using a linear regression model. So then post that I'll be using lasso regression, and later on I'll be using a random forest regression as well. So the definition and fitting syntaxes aren't very different. So I'll show you for one. So let's start with a linear regression. So linear regression. Let's import it from sklearn.linear model. Import linear regression. Now we'll store that in a variable. Let's say linreg, remove the k, equals linear regression parentheses. Okay. Next, what we'll do is we'll fit or provide the parameters, which is x values and y values, to the model. So x values comma y values, x dot values dot y dot values, and for prediction we'll use linear dot predictor variable, and we'll use the model dot predict function in order to get the predicted value. So linreg dot predict, and in bracket we'll have xval dot values. So basically we'll be predicting on xval. So this is it for the linear regression. We'll copy this same for lasso regression and so the syntaxes are almost same. So if I show you, this is for the lasso regression. Lasso also takes an extra variable which is alpha. So I'll provide alpha equals equals 0.1. And for random forest, the syntaxes are almost same. So this syntax, it also takes a variable which is called n estimators. I'll be providing it with 30. So yes, these are like hyperparameters, so you can just tune in based on your preference and score in order to get a better accuracy for the model. Now what we'll do is compare these different models and analyze their result. So let's do from sklearn.ensemble. No wait, sklearn metrics. Let's import R2 score. Let's also make a array for the names of the table that we'll create later on. So predictor names equals linear regression. The second will be lasso regression, and the third would be random forest. Now let's just define for the column. So the matrices that we'll be analyzing is RMSE, comma R2. You can also include other matrices here, so it will only increase the like a few lines, but you can do the same. Equals. I'll just create a dictionary. So we have RMSE. So basically here we are writing the content for the table. So RMSE equals RMSE. We are using utilizing the function that we defined earlier. In bracket we are writing linear regression predicted, comma y value. So basically the predicted and the test values or the target values that we had, and then comparing it the RMC value and putting it in the table. Then we have R2 score as well for the linear regression. So we write R2 underscore. We'll be using the same variables. So let's write y values, comma linreg underscore predicted. We're going to do the same for lasso prediction and random forest as well. So yes, that's it. Now let's write the result table. So result table equals pd.data frame. We'll convert it into a data frame. Bracket result under root values. And we'll give the index equals predictor names. So that's it. Let's run all the cells that we have written. So let's okay, we forgot to write the variable as well. Let's just run the cells. So we got an error. Let's see what it is. So linear predicted not defined. Why is it so? Okay, so here we have in all short letters and we arrived an R capital. So let's change R into capital. Run the cell and run the cell back again. Okay, shows error in pandas has no. Okay, so the D should be capital here. I have written data frame D in small letter. So capital D. So this is how debug a program after you've written once. This is a thing that will always happen once or twice. Predictor names is not defined. So okay, I have written predictor name here and predictor names here. So let's just change to name. So I hope it should work now. So yes, so this is the result that we have got. Feel free to analyze it and understand more about what these all matrices mean and how these affect data and accuracy of the model. So this is it for the project, guys. I hope you found it informative. If you did, make sure to like and share and subscribe. If you have any doubt, feel free to ask in the comment section below, and I'll be coming up back with a new project. Thank you.